Howdy once again, it's Mr. Pete, your YouTube shop teacher, and I'm standing at the Bridgeport mill. Let's make a project today, and we'll call them the PETEBLOX, riser blocks for your clamping system. As you know, there are countless different ways of clamping your work on a Bridgeport or a milling machine table with the T-slots. I still favor these old U-clamps, but there's all kinds of other clamps, such as these right height type clamps. But in some cases, this type of clamp doesn't reach quite high enough. I suppose it might on this particular job, but the ones that I've favored for a long time in my shop were these Morton brand. They were made in Canada. Riser blocks, I guess I'm not sure what you should call these. And they are a series of 1/8" plates that can swing aside and give you any desired height that you want for clamping. That, of course, is way too low, but I don't think these are available anymore, and they are marked James Morton. I've had these for many years. I'm not sure how well you can read this, but you can see they're made in Canada by the James Morton Company, and that's the same company that makes the right height clamps, and I'm not sure if they're still in business, but I really do like their products. At the high school, one of our projects was these screw blocks, and they could also be adjusted to any height, and I made them in different sizes. This was a student project, and they just had an internal and external thread. They're handy for other purposes as well. These Morton blocks, as I remember, came in different heights, and I believe I had some shorter ones in the high school, and they could be stacked as well. And that's why the fastener here, the bolt, the peg, the pin, whatever it is flush, so that you could put one on top of the other like that. Very universal. It's a great product, really. Most of you are probably familiar with these sure grip type of step blocks made by many different companies, and they are much like the Chinesium ones that can be adjusted to different heights, either in that manner or like this. These clamping kits from overseas are pretty handy, but I really don't like them, and I'm not sure why I do not, but that's a set of 3/8 diameter, that's a set of 1/2 diameter. Okay, now that you know what I'm making, let's select the stock. Now, the original material here is about 119, 120 thousandths, and this is scrap steel. It's a drop-off, so it's about this, well, a little less. It's about 100 thousandths, which is actually about 9-gauge steel. But you're going to use whatever you can find. 1/8" would be better, but you know, it could be 1/4 inch, could be whatever you want. Now the very bottom piece I'm going to make out of thicker stock because I'm going to have a bolt that goes in there and gets threaded. So that'll be the bottom piece. And again, you can make these any height you want, depending on how many pieces of steel you want to stack. So I already went through the laborious effort of sawing these pieces, and the material that I had was just a little wider than what you see here. And these are longer than what I need when you compare them with this. So later on I'm going to cut those off, but they're all about the same width because I used a stop, but yet they're going to vary a little bit. Now off camera I'm going to do the tedious job of deburring because we got all kinds of saw burrs, and you just really don't need to see all of that. Now you can go to your local recycler or scrap dealer and try to find some material, but let me show you what you're going to find in the box stores. As you know, just about every store has a rack of overpriced steel, flats, angles, rounds, and all of that. And I did find in that rack in my Ace hardware store some 1/8 by, what is it, 1.5 by 3 foot. But that's about an $8 or $10 or $12 piece, and you'd need at least 2 of them. So it just costs too much to make this if you have to buy the material. Well, that was no darn fun. That took about a half hour. There were a lot of saw burrs, but they cleaned up pretty nicely. Well, these would have been stamped out on a punch press, holes and all. Perhaps there were some burrs and they would have tumbled them. If I had a tumbling burl, I would have tumbled these. Tumbling tumbleweeds. Well, here's the game plan now. I got to drill a 5/16 hole through the whole stack, but I'm not going to do that all in one. I'm going to do it in groups of, I don't know, 2 or 3 on the milling machine. And this will, of course, be the bottom, as I told you, like that. So these will be cut off eventually. I think I wrote down the size or someplace, didn't I? Yeah. These are 1.5 wide by 2 inches long. I'm not sure what that hole's for, unless it had something to do with holding them while they did a second operation. Okay, here is the living blueprint. The 5/16 hole will be 300 thousandths in from the bottom and 750 thousandths, that's 3/4, from the side. So I'll make a setup on the Bridgeport mill, but of course you can do it on a drill press. Don't do it with a hand drill. Alright, let's have a look at the setup here. Using an edge finder, which is probably overkill for this, I have, and I've got a stop here for the work. So the work will be pushed up, and I'm, again, 300 thousandths in, and I touch the edge of the vise and moved out half of, actually these average about 1.555 each. They're not all the same. You know how it is cutting off with a saw. They're not all the same. So half of that on average is 0.777. And I'm using the digital readout for that. I don't believe I'll show you. The work is setting on 2 parallels so that I will not drill into the parallel. So I'll bring the work up against like this. And I'm going to do 4 at a time, held with a vice grips, pushed up against the stop, and then the vice tightened. And I'll change the tools. This is a bit of a repeat here, but taking 4 of them at a time, remember they will vary in width, so there'd really probably only be one of them that would be tight in the vise when you have a stack. So I'm pushing them up against the stop, tightening the vise, and then using this type of vice grips, which I happen to like. That'll hold them all together. And this is a center drill naturally, and a 5/16 stubby. I probably could get away just by going in with the stubby. And it's just a matter now of drilling straight through all 4 pieces. Wear your glasses. most of the drilling is done. Now this may seem foolish, but I still have them in stacks as I drill them marked. Why? Because if some of them are flipped over, they may not line up. I don't really know that for sure. That's probably overkill, but that's just my MO. Meanwhile, back on the milling machine, I have two of these 3/8. These are the bottom pieces now to drill and tap. I will try power tapping, but I have my doubts, so I'll center drill it. And that's the letter I, a stubby letter I drill, which is the tap drill size for 5/16 24. And that did work quite well, power tapping. That is hot roll steel, and that's a tapered tap. But it's very important that this hole be drilled and tapped perfectly straight, that is perpendicular. I'll do the other one off camera. Well, there's a bit of deburring to do, mainly on the bottom piece, and I will spare you that agony of watching me deburr. You know, whenever you started in a factory, they put you on the burr bench or as a deburring bench, but often young men would work till noon and would not return ever after lunch because it was so miserable. Have you noticed in your travels that you virtually cannot find fine threads that are not hardened, grade 5 or 8? This, of course, is a coarse one, and they're readily available. I think it's grade 2, any place. And you pay a premium for these. And why do I tell you that? Because I want to turn the head down a little bit on this. And, well, I was able to do it with a carbide, but, or you could anneal it if you wanted to. Well, why am I rambling on that? Well, these are 2-inch high stacks, so I'm going to build some stacks. And I wanted to use a fine thread, and I forgot what my original intent was on that. But let me go ahead and put a stack on here and show you what I'm getting at here, what I'm blabbering about. At the high school I made a tumbling barrel because it would have been so easy if I could have tumbled these to get the burrs off. So there's 4. I don't even know how many it takes here. We'll see. I always cut extras, don't you? And then I need enough. One more maybe, huh? Alright, let me snug this up just a little bit, and the original intention here was for me to use some Loctite here. You know what I need? I need one more, but I'm not going to take it apart yet. And these stacked up pretty evenly, didn't they? Okay, we don't want these so tight that you can't swing them. So my intention, of course, was to Loctite this just right, but even a better idea, I thought, would be to use a Belleville washer. You know what a Belleville washer is? Of course you don't, and neither does anyone at the hardware store or the box store, but a Belleville washer is cup-shaped, so you can apply tension to it. Well, you can't get those. However, you can get these wavy washers, but I don't know why, but you got to buy them in metric. The 8mm essentially fits on a 5/16. But, so I planned on making 2 sets of these actually. One short stack and one long stack. That sounds like pancakes. So, alright, where am I going with that? Okay, But what is the objection to this bolt head? And we made some at school with the bolt head. But if the bolt sticks like this, you can't stack them. So I think the whole idea by Mr. Morton was to have them countersunk. So I am going to countersunk them. Boy, that was a long intro for nothing. But what I did here is I took some of those grade 5 bolts, I turned it down to take the hex off, and then I made it, oh shoot, I'll have to measure that thickness there. But that will allow me, if I counterbore one of the top piece, to put that in flush. Is that clear as mud at all? Alright, let's review. These pieces are about 102 thousandths thick, so half of that's 50 thousandths, so I turned this bolt down to 56 thousandths, 55 thousandths. And I counterbored my sample here. That's just junk. And you can see that that will fit in there flush. So let me take the counterbore off camera and counterbore the top piece. You don't need to see that. This is a 5/16 counterbore. Alright, that's how it's going to fit. Well, how am I going to screw that in there? Oh, I went to Fastenal and bought some screws that had a slot on the other end. How convenient. Then the whole idea is with some Loctite there, just snug it up so you have what I would call a friction fit. You don't want them to slide around like a brand new deck of bicycle cards. By the way, what's with cars? Why do they call them bicycle cards? You can't ride them. You can cheat with them. So it's fairly even right here. Oh, how wasteful. That's all got to be cut off and thrown away. And then the idea was, if this didn't turn out semi-smooth, one could mill it off. Well, I will saw this off and then mill it on the ends. But, you know, after all, how smooth is that? You know, not perfect, doesn't need to be. Let us remember what this is for. What did I call these? Peat stacks? Okay. Well, what do you think so far? So I got to go ahead and assemble the other batch. And my marking here was all for naught, was it not? And of course, I'm not going to be able to use these, but if I make another short stack, I would probably forego the extra effort. I did that all off camera a couple days ago during my rehearsal. You know what, I added one more to the stack. That moves the bottom of this screw just a little bit away. I don't have to grind it off. And guess how many pieces I have left here? 17. Hope I don't screw it up. That was number 18, my sample. So, over to the bandsaw. You don't need to see that. There's nothing more miserable than cutting through thick steel, is there? Well, that was no fun. Ready to mill. The original product here has a nice 1/4 inch radius. Mine's not going to get quite that much. I'm just going to break the corners nicely here, depending on how much work it is on the abrasive sander. So let's see how that goes. And I don't want them to swing out on me. I'm trying to keep them stacked. I'll tighten that as tight as I can get it. See what happens. the next day. As a matter of fact, it's New Year's Eve day. 2019 is about gone. And I was semi-prolific this year. I must have turned out 200 videos in all, so check them out. And don't expect as much next year. Anyway, this turned out pretty good. I did put Loctite on there last night before I went to bed. And I think I got just the right tension on there. I don't believe that's going to loosen up because that's high strength Loctite. I did, you saw me on the belt sander, round those corners off a bit. Not as much as I would have liked, but good enough for who it's for and what it is. Well, now I have to cut this one off, and I'm not going to show you any of that because that's just a total repetition. So I'll get back to you through the magic of television here in a minute or two, even though 2 hours will have lapsed. But one other thing here, on the genuine Morton blocks here, they are countersunk, and I guess I forgot to tell you that those pins were staked in. So I'm sure this top piece and bottom piece is countersunk, and you can see where that's been staked, and they did get just the right tension on that. So that is a brilliant design, and of course I take no credit at all here. Billy Hefner invented it, and Morton distributed it and manufactured it. So all right, let me cut that off. Be right back. It's about a half hour later, and I've just completed the second set of PETEBLOX. Now the only thing I still need to do here is to back this off just a little bit. I don't need to take it all the way out. And a couple drops here of this, well, there's more than a couple. And then I'm going to snug it back up. And in an hour or two, we got the right tension there. Now, if the tension isn't right, you know, if they swing like that too freely, with the Loctite in there, you can make another adjustment. Even after it's set, you just force it a little bit. All right, so that's done. Handy as heck. You are watching tips number 614. There is a possibility that there will be a tip 615, but there may not be. So you'll just have to watch for that. And of course, I'll be beating that horse to death with the second version of these. And let me explain that to you. That in this one, of course, I used what I would call strip stock, because it's just narrow. I would like to have had it be the perfect width, but it wasn't. And that's why I ended up with so much scrap. Some people would save that. That goes to the recycler. So, what's the difference there? Well, I may go down to school in the new year and see if the boys can cut out on the plasma cutter the blanks. If that works out, you know, something like what you see here on this piece of metal, and I would need, again, about 35 of them, and the radius would be on there, so that possibly the only thing I would need to do would be to deburr them and get the slag off and drill the holes. I'm not going to attempt to have them pierce the hole because it would be too inaccurate, I believe. Maybe a laser cutter could do that. And one other point here I think I should make, you could very well drill through the whole stack at the same time. I just did it in groups of 3 or 4, and I'm not even sure why. I just thought the hole might go astray. That was my reason for doing it in smaller numbers. And you know what I could have done also, since I had a lot of extra stock there, and I used to do this at the school all the time. If I was making something like that, I would weld one side of it and then saw the welds off and throw them away, but that held everything in perfect alignment. So that was one of my MOs. Well, there's a nice little winter project for you, a pair of PETEBLOX in whatever height you desire. Yeah, I think you'll find them very handy on your milling machine. Hope you liked the video. This is tubalcain saying so long for now, and be sure and watch my 1050 other videos. Happy New Year.